Thanks, guys. All right, so yeah, as Gaurav said, I'm going to talk about collaborating using Git and GitHub. Probably 80% of this is just going to be a talk about the basics and concepts behind using Git, which are really important, and then we'll sort of add collaboration GitHub a little bit toward the end. But a little bit about me. My name is Dzombak. I work for a company called Nutshell in downtown Ann Arbor. I just graduated back in May, so I'm still, new at the real job, real person thing. Um, the obligatory quick plug, if you guys are looking for part-time work, internships, whatever, Nutshell is a really cool place to work, and it's conveniently located like 10 minutes from here. So you should check us out, nutshell.com.
Chris, how many people work there right now?
11 people work there now. We've grown.
6 of them are engineers.
6 are engineers. Yeah. And it's a fun place to work. At Nutshell, I'm half of the mobile development team, meaning I work on our iOS and Android apps, which is fun. And we use Git at Nutshell. During this talk, I'm going to be sort of walking through slides, demoing stuff in Terminal, so it'll be back and forth, but the slides will be online later on Michigan Hackers GitHub repo or something. People are nodding at me. So you can refer to those later. Okay, Git. This long definition here is from the Git website. Basically, Git keeps track of the files in your project and their history. So that lets you see what changed, when it changed, who changed it. You can go back in and undo changes that broke things. You can know who to blame when stuff breaks at like 4 a.m. before something's due, all that fun stuff. It makes collaborative work just a lot easier because you can have people working independently on different things. It'll track what's going on and let you merge everything together later without creating too much of a mess. Unless you're really determined to make a mess, you can still make a mess with things if you want. Installing and setting up Git is easy. I will link you to this helpful GitHub article because that's on the lower end of like priority stuff to walk over tonight, and because it's really easy, I'm very confident all of you can figure it out. If you're using Linux, it's really easy. I'm sure your package manager, whatever you want to use, you can type apt-get install git or yum install git or whatever. On OS 10, you can install it from the links on this page, or if you have Xcode installed, you have Git installed already, or if you are really, really geeky and use Homebrew or Mac ports, you can install it and probably should install it through there because that's frequently updated and all that stuff. But it's easy. It'll take you 5 minutes. So I figured we'd start talking about Git just through the lens of using Git for like your own project, just by yourself on your own computer without even adding another server. I know this talk is called Collaborating with Git, but it turns out that just a single user Git repository is a really nice, simple way to introduce these core concepts. And Git's useful for just one-person projects too. If I had $1 for every time I open just some tiny project and start hacking on it, and like half an hour later, everything's broken and I don't know how to fix it and it's just terrible, I'd be retired by now. And that would be nice, but I don't get $1 every time that happens. So you should use it. So to jump right in, type it, if you change to the directory with all your code with your project in it and type git init, that'll initialize what's called a Git repository, which is just sort of your collection of all your version data in the current directory for that project. And that's all there is. And then you can start keeping track of versions and stuff without having to connect to an extra server or anything like that. It really is that easy. So let's go over to this terminal where I have this really awesome project which prints hello world. And you can run it, and somewhere here it prints hello world. But we'll go ahead and type git init, and it says initialized empty git repository. So we can now add stuff to this and keep track of what's going on and everything. Also, incidentally, when I switch things and hit enter, I have this thing that will display keystrokes, which let me know if that's annoying, but I thought it might be useful. So onto a key concept in using Git are commits. When you change a file in your project or change many files, you can assemble a set of related changes to all those files. Let's say you fix that typo that was in my Hello World program. or I don't know, add picture taking capability to my cool new iOS app. I can collect all the changes that were required to do that into one commit, which is just sort of like, it is just a set of changes that you made to your code. Yeah. So your development history basically is just a stream of commits made, over time by you and whoever else is working with you. And you can walk through that, look at your history, look at who changed what, when, all that kind of fun stuff. Like I mentioned, you can go back and revert a commit if it introduced a bug or didn't fix what you actually thought it fixed. Did that at work today. That was fun. And you can also go back and see what your whole code base looked like at a specific commit or at a specific point in time. So that's sort of a core concept to understand. And I don't know. Actually, I should have asked at the beginning, how many of you guys are at least kind of familiar with Git or with source control in general? Okay, good. That's a good number. So in order to create a commit with a set of changes, so I went into my iOS app and added the cool new picture-taking feature. I need to go through and collect all the changes that were related to adding that feature. And you do that by adding the files to a special basically like a staging area, where at the end of, once you're done organizing your stuff, you'll take all the changes that are staged in this staging area and create a commit out of them. So you select what changes are going to be included in a commit by saying git add, and then, this file, whatever. And you can type git status to see the status of, what is staged, what's changed but hasn't been staged, and all that. So if we go back to the terminal here, this all makes sense so far, more or less? Okay, cool. I see a couple people nodding. That's good. So if we type git status, all right, so we see that we have this hello.py file that's not tracked yet. So let's go ahead. We'll add that. Remember, git add hello.py. And now, git status. So, changes to be committed. Awesome. So now, that went from untracked to be committed. So now when we go to commit this, that'll be included. So life will be good. So how do we actually commit that to the repositories, like a discrete point in time when everything worked, more or less? There we go. Type git commit. And it'll prompt you for a commit message, which is just a short description of what you changed. I will take a side note now to say that writing good commit messages, or at least decent commit messages, is really, really, really important if this is going to be useful, especially if you're working with other people. I worked with a guy on a group project, I think a year and a half ago, in, I think, operating systems, who insisted, he didn't want to use Git in the first place, but he insisted that every one of his commit messages would be either like the letter A or just like, hi, Chris, which is just beyond useless. Writing bad commit message will only annoy your collaborators, so don't do that. So let's go back to our terminal here, and let's say git commit. And it'll prompt me for a commit message, so we'll say initial commit of hello world, and exclamation point, save it and close it, and we end up back here. Cool. If you type git status, it says nothing to commit, because we just added that. So now that hello.py file is tracked in our repository. So if in the future I go and let's go back here, can mess up hello.py, introduce some kind of bug like that, I can still go back and get back the original working version. And we'll get to this command in a second, and just like that, we're back. It's magic, kind of. So how can we tell a little bit more concretely what has changed since our last commit, and what has changed in the staging area that we talked about? It turns out Git has a tool to do that. If you type git diff, that'll show you what changed since your last commit, and git diff -s staged will show you what changes are staged to be included in your next commit. And git diff especially is really, really helpful. So let's go back to our hello app here. So it'll print another line now. And if we run it, yeah, so that happened. So you type git diff, it shows you, yeah, we can see what changed in this line, which is helpful. Now we can go ahead and stage that file. You can see this, so now that's staged to be committed. And if we go ahead and we can see what all differences are included in the next commit. And type commit, and there we go. You guys also get to see evidence that I actually have no typing skills whatsoever, which is fun. Yeah. Glad I can be somewhat helpful. This is a little bit of a side note that you don't quite have to worry about just yet, but let's say you're working on a C project. When you compile your project, you'll end up with object files, your .o files, in your build directory or just somewhere. Those don't have to be in version control. And so you can really easily tell Git to just ignore those, so they won't show up in your status messages, they won't show up in diffs or anything like that. Git will pretend like they aren't even there. And you just add a file called .gitignore to your repository, and you can specify wildcard.extension or various patterns in here. And then you just go ahead and commit that git ignore file to your repository, and those files will be ignored from there on out. That's something that I just thought was good to mention here because I didn't think where else it was good to mention. And since almost all of the projects that U of M does are in C, you'll want to exclude some files from your repositories, I promise. So next up, there are some useful commands for viewing the history of your repository. Git log will show you just a log of every commit so far in your repo. If we go and do that, you'll notice, where's terminal? So 2 commits so far. You'll notice that each commit is identified by a hash. And actually, the hash is a little bit longer than that, but as it turns out, 7 characters is enough to uniquely identify pretty much any commit. But don't worry about that. Basically, these 7 characters uniquely identify each commit in your repository. So that's sort of the canonical way to refer to commit. Let's see. So you can type git show, and then one of those hashes, or SHAs as they're called, git checkout SHA will let you see the state of the whole repo as of that specific point in time, and git checkout master will bring you back to the present. We'll talk a little bit more about what master actually is in a couple minutes. But for now, let's go ahead and just see what this gives us here. I'll copy that, and then yeah. See, I can't type. It's true. So this shows us what I changed in that initial commit, and that was I added this version of this file. And what other? Oh yeah. So let's see what if we look at the current state of things. There's all this stuff in here. So let's say I want to see what the project looked like way back at the beginning. Git check out that. Ignore this message for now. That'll make a little more sense later. But if we look at that file now, it's back where we started. And we're back there. So that's one of the useful things you can do with history with Git. Make sense so far? Yeah? Okay. Cool. So on to branching and merging. As it turns out, just working on all your development in this one line of commits gets to be kind of a pain after a while, especially on a bigger project. An iOS app that's been in development for 3 years. So what you can do, and something that you find especially at companies like Nutshell or most companies who use Git, is if you're going to start working on adding a feature, like say the cool photo taking thing for an iOS app, you can split off from the main what's called the main branch, which is master, into your own branch. You can name it whatever you want to, and you can make a series of commits. Just in that branch, which if you visualize it literally just as a tree, you have your master branch, and then you can branch off there to add whatever features you want. So the kind of theory there is you can branch off break things, add features, add your feature, do whatever crazy things you have to do. But the master branch, the sort of main branch that we've been working on so far, stays pretty much always in a not broken, like releasable, ready to go state. And then what you do is once you're done working with your own, branch, adding your cool feature, you fixed everything you broke when you started. You can merge it back into master. And there's some commands to do this. That's one of several different Git workflows, but it's one that works nicely and is pretty simple. So, some useful commands for this. If you want to create a branch, this is the command for it. I won't read it to you because you can read. You can switch to a branch that already exists with the same command, just without the -b. You can list all the branches in your repo with git branch -l. And let's say I'm back on master. I want to merge that feature branch that I was working on back into the master because it's done, more or less. It's ready to go. That's git merge, and that'll merge your branch back in. So let's go ahead and kind of demo some of this stuff. All right, let's see. So let's start by creating a branch. Let's add, what can we add? I don't know. Well, we'll do something. What should we do? Any ideas? All right, we'll do text input. Cool. Switch to a new branch, CDZ text input. If you're working with multiple people, it's helpful to prefix branch names with like your initials so that everyone knows like what's going on with, or at least who's responsible for each branch. Maybe not so important now, but it's useful to know. So let's go ahead and change something here. Let's go over here. Was that no, somewhere here. Okay, well. Let's add a new one, actually. Cool. Let's run that, see if it actually works. Cool, so that works. And so let's check what our status is, what's going on here. We modified hello.py. Man, what changed? Oh, we added name input. That's pretty cool. Let's commit that. Well, first let's stage it, or add it to our staging area. See what change that we're going to commit. All right, that looks good. And so let's go ahead and here's a useful thing. If you don't want your editor to pop up every time you make a commit, because that's annoying, type git commit -m your commit message. So it's not a very good message. Don't actually write commit message like that. Also exclamation points, man. Computers, man. I just... All right, so cool. So you see we added this commit here. We're on our CDZ text input branch. So let's say this feature is done, because it seems to work. So let's go back to master. Git merge CDZ text input. There we go, just like that. This branch, I should have showed you the state beforehand, but the changes from that branch, which were just this one change, are now here. Cool. Does that branching, merging make sense? Okay, good, good. So, what happens if I change something in two different branches at the same time and then try to merge them? It's an excellent question, to which it sounds like there's no good answer. That's because there's no good answer. Git will tell you that you should fix this, and then you should commit it as the result. So, what can we do here? So we're on, as my little prompt there thing says, we're on our master branch now. So let's say I'm going to, well, I'll fix that typo for sure. Okay. Add that change. Cool. So we fixed that typo. Awesome. Cool. Now let's say, man, I want to go back to well, let's create a new branch here. We're going to add awesomeness, apparently. See, that's telling me that that didn't match anything noted yet. So we'll go to actually create that branch. Come on. There we go. And let's add something awesome here. And maybe that'll mean actually, formatting things nicely. You notice we're going to change the same line here that we changed on master. So let's see what happens. We'll commit that. And try to merge that back into here. Now remember, in our previous commit, we also changed that line. So let's see what happens. Oh, why did that work?
We branched that you had already committed.
Ah, good call. All right, well, yeah.
Creative branch added earlier.
Yeah.
I believe in you.
All right, so we changed that. Things are still broken. I will register sublime text eventually, I promise. And this actually, well, this isn't going to be too interesting demo. Anyway, Git will give you directions on how to fix a conflict and commit it. As you see, it's actually harder than you would think to actually create conflicts. If you have screwed up everything and want to just go back to your last commit, git checkout dot works really well. It's the hazards of typing or of trying demos that you're typing along with it. Things never really work as you'd expect. So, questions so far? Does everything make sense? Yes.
Well, it's just kind of just purposeful, but you can do quick commits just by adding the -8 flag. Is that something that, what's the benefit of staging all this up for commitment that you said for commit history-wise, this group of changes kind of goes together?
That's a lot of times in a larger project, you'll be working on, if you're not super diligent about always like staging and committing and branching and everything, you will find yourself ending up with changes related to multiple different things at once. So, I might have been working on, adding picture taking to an iOS app and then gone back to, fix some other bug that some user found. But I might, end up having changed both those things. But, those aren't really related, so they do belong in different commits. And so with git add, I can stage like just the one bug fix and commit that. And then I can, commit the, I can commit the picture taking or whatever I said I was working on with git, commits -a or just staging everything normally. It just gives you a more fine-grained way to control what's in your commits, which means you have a cleaner history, which is useful. But if you make just the one change, then that's fine to use that. Okay, moving on. Working with remotes. Remotes are, as the name kind of sort of implies, servers that have Git repositories on them. Git will let you communicate with these servers, share your work with just yourself or with others. Now, as we've implied, the popular place to host Git projects is GitHub, and they'll let you create a free account, and you can use that to share your projects, your code, and they will walk you through the sign-up process. Which is simple. And they will also walk you through the process of configuring Git with your name and email, which is also really, really simple. So let's skip ahead a little bit and try creating a GitHub repo in order to share this wonderful Python Hello World program with the world. Let's also make this fit on the screen. There we go. We can ignore that. All right, cool. GitHub has a cool feature where, like, if you know this is going to be, a C++ project, they'll add one of those git ignore files that I mentioned earlier, which will, so your repository will come pre-configured to ignore all your object files and stuff. But we're not going to do that for now. We're just going to create a repository. So there we go. We have a new repository we can use to share everything, and life is great. They have two really useful things here you'll notice. I don't know if you guys can read that. But they have instructions for creating a totally new repository based on this thing that we just created. Or if you have an existing repository, which we do because we were just working on one, they have instructions for that too. So let's go ahead. I think I have a slide about this. I do kind of have a slide about this. But we'll talk about that in a second. So we can literally just copy and paste this stuff. All this command does, where's my terminal? Is it tells Git. Can you guys read this all the way back there, more or less? Okay. All this does is tell Git, hey, we're going to add a new remote, which is a server with the Git repo for this origin, and this is where it is. And there you go. And then the next command tells Git to go ahead and push this repo to that server. And we'll talk about what this command means in just a second. There you go. And that worked. Life's great. If we go ahead, If we go ahead here and look at this repo, all our files are here, all one of them. So let's talk a little bit about what this actually did here. So git push is the command that we just executed. All that does, that pushes all your commits, all your changes, everything up to a server. Now this gets a little bit complicated maybe, but just plain git push, if you type it, will try to push all the branches that it knows the server is aware of. It'll try to push any changes to all of them at once, which isn't necessarily always a good thing. Usually it won't break anything, but probably a little bit better practice to say git push origin head. Now head is sort of Git magic term for just the branch that you're currently working on. So what that command will do is push push whatever you're currently working on to origin, which is the name of that remote server that we added, or git add remote origin. And head is the current branch. So that's what we did here. You could just as well have typed head here instead of master. Little bit of a just stupid distinction that is not worth worrying about right now is if you're trying to push a new branch to the server, you should type git push -u. Otherwise, if you're trying to push a branch that exists on the server, you can use the bottom command in this slide. That's probably best. So I think I had one or two other things here that I wanted to make sure we look at. Yeah. So here are all our branches, and we'll try and demo using that git push -u just to push one of these other branches. So let's check out one of the other branches first to work on it. And if we go to GitHub right now and look, right now GitHub is only aware of that one branch, the master that we just pushed. So let's go ahead and let's say that we think it's really important that everyone sees this text input branch that we added a while ago. We'll just type that. That's not that important. And there we go. If we go back to GitHub in a second, did that work? Yeah. Well, it'll take a second to update, but it's there, I promise. Cool. That's nice. Cool. So, adding collaborators to a project. This is what everyone came here for, is collaborating with Git. So, let's say that I want to collaborate with, well, I'll actually go over this slide first. Basically, you go to this page, you substitute your username and the repo name, and you can add other GitHub users as collaborators on your project. Your collaborators can interact with the repo just like you can. They can commit to it, push to it, pull from it, do all that sort of stuff. This is great. This is a great way to work on class projects with people, all that sort of stuff. So if we go here, and I'm going to zoom out so this actually fits on the screen, but go to admin, collaborators, and let's say I want to collaborate on this with Max. Max, do you want to work on this with me?
Sure.
Cool. So I'll type in his username and add. And yeah, now Max has access to screw with this repository at will. So I'm confident he will do in short order.
Actually, just
Perfect. Great. We'll get to those in a minute. Thanks for that, by the way. Now, especially for class projects, you might be wondering, but what if I don't want everyone to see my GitHub repos? So by default, GitHub is designed for collaboration on open source projects primarily. So they're public by default. Anyone can read, look at your code, all that sort of thing. Your collaborators can actually write to the repo. If you pay GitHub for an account, you can create some number of private repositories which only your collaborators can see, can read, can write to, all that sort of stuff. And you guys, being students, can actually get a free upgrade to a small GitHub plan to have a couple private repositories, which is really useful. Just go here, click on on this link here, and that's great for class projects, thesis, or research towards a degree, as it says there. So I definitely recommend that you all do that. So moving on, does this all make sense so far? Is this Did you have something? Okay. At the end of the song. Oh yeah.
Can you go over what branches are for again, real quick?
Yeah. So branches. Branches let you sort of go off. Oh yeah, we have a whiteboard. I totally don't have to use hand signals. So we have development going on. Everyone's writing code and making commits at points in time in master, which other fun things you guys get to learn about when you have horrible handwriting. And that's all well and good, but that is a sort of a general rule. You don't want things in your master branch to be really, really broken or have horrible bugs in there. So if you know you're gonna be adding something that is relatively big or even small, what you can do is sort of is branch off, and this lets you make a series of commits all on your own that no one else can see, that doesn't touch master, which still happens, on its own time as all your collaborators and work on there. But you can, in this branch, it's totally isolated from master, so you can, break things, make your own series of commits, and add your feature, or do or fix whatever you're trying to fix. And then once that's all done, you can merge it back into master once you're confident that won't, break everything for everyone else. Does that make a little bit more sense?
Yes. Okay.
Okay. I think that, so yeah, and then merging, is like that. You go right back in. There are tools that will give you pretty graphs like that, much better than I can draw.
Explain the problem you were trying to create earlier, the merge conflict.
Yeah, good call. So, yeah, so a merge conflict, which I failed at creating because Git is too smart even for me. What would happen if, so let's say at this point, someone else who was working on that changed that to print, hello world with punctuation, no typos, and everything. And here, I changed that same line of code to print in all caps. Right, so something totally different. When we go to merge that back in here, Git will look at the history of this file, and it'll say, wait, well, so this line of code changed in both of these branches since they branched off. It changed here when when Max fixed all these typos and added punctuation, and it changed here when Chris started trying to troll everyone. And so it won't know. It doesn't know how to merge two lines or merge two different changes to the same line. And so it'll ask you, so what should we do here? Which of these lines is correct? Which should I use? And so that's what that is. And that's actually relatively uncommon, believe it or not, to have to fix those. Unless using Xcode, because Xcode is painful. But does that make sense? Do you think does that make sense to more or less everyone here? Cool. All right, good. So let's say that you've been added as a collaborator on a class project by someone else who created GitHub repo. How can you pull down that repo and start working on it? Well, there's a great command, git clone, which will pull down that repository to your hard drive or clone it in Git parlance. And so let's go ahead here and let's find somewhere here. Yeah. So if you go to the GitHub project page, if you've been added as a collaborator, right here it'll give you, so it says read plus write access in really tiny letters. But if you copy that, and let's go to demonstrate how we can start doing multi-user things, I will log in on a totally different machine, so it looks just like I'm another user. And I'll pull down this repo. And so just like that, wow, cool. Don't have that here yet. That's a cool thing that I don't have implemented on the server yet. So there we go. Our files are here. That's great. That looks like what we wanted. Great. Everything's great. So just like that, I've pulled down this repository. I've pulled down. Actually, let's do that. I've pulled down the complete history of this. All this important data is on my computer just like that. So it's really that simple. Cool. So then let's say so that someone else, Max has made changes in this repository, and I want to pull down his changes into my copy. Well, the command for that is aptly named git pull. And that just will pull the current branch from your remote, from origin, and merge them into your current working branch. So let's go ahead, just on master here, right? We're on that branch, and add. Actually, let's take the opposite route and remove things from this to make it simple again. Use nano like all the cool kids, and we'll add. So, great. So we can see what we changed there. Let's go ahead and commit that, and we'll demonstrate pushing that up to the GitHub repo for others to look at and play with as they please. Yeah, sure. Why not? So remember how we push stuff, since we know this branch master already exists, so we'll git push origin head, and lo and behold, it'll be up on GitHub. If we refresh this page, hello, there we go. Yeah, there we are. And now, if we go back to my local machine here, so this is, this could just as well be someone else's machine. We'll go back to master. Actually, and let's look. So on my machine, we don't see that yet because some other guy on some other server just changed this and pushed it to GitHub. But let's go ahead and see if there's anything new. There we go. Man, someone changed hello.py. Man, what happened there? Oh, jeez. I wonder what that commit is. Yeah, there we go. And so that's how. And so those are the two key commands for collaborating with other people: push and pull. It's really not too complicated. Yeah. That seem okay with everyone? Good so far? Yeah. So clone is used for pulling down the repository for the first time. And then pull will pull down, just the changes since you last pulled. Okay, cool. Moving on. So, text font fail. Anyway. So let's say that, I know Max, my collaborator in this repo, has added another branch and pushed it to origin. And let's say I want to check out that branch and start, working on it myself. This look he's giving me tells me he's pulled some shenanigans, I'm sure.
No, we'll do a pull request from a different branch.
Okay,
I
good.
can do a different branch.
It's okay. So you'll the way to do that is a little bit, I don't necessarily want to say complicated, but there are a lot of steps. So the first thing you do is type git fetch origin, which will pull down not just the latest commits for the branch that you're on, but it will pull down all the branches and all the recent commits from the remote server for you to peruse. So that's sort of the important distinction here, is that git pull will pull just for the branch that you're currently working in. Git fetch will fetch everything. And then once you've done git fetch, your local machine will be aware at least of Max's branch or of someone else's branch, and you can use for the first time git checkout -t origin someone's branch to check out that branch. The -t means that Git will remember, okay, hey, I'm creating a branch called someone's branch, but it's going to track this branch from the server. That's not particularly intuitive maybe, but once you get a little bit used to it, it's really not bad. After that, once you've checked out their branch for the first time, you can just type git check out someone's branch to look at it, work in it, whatever. So let's go ahead and see how this might work. We'll go back to this this other server somewhere. I have git co alias to git checkout. Don't worry about that. So CDZ new branch. That's a great name.
So, Chris, I actually just pushed a new branch to your
Ah, perfect. So ignore everything I'm doing. So Max has informed me that he has pushed a new branch to my repository. I want to see what this branch is. This is really exciting. So git fetch will make my local machine aware of all these branches and changes on the server, and we'll give it a second. Oh, someone created a branch called max-branch. Cool. Well, let's check that out. Start working. See what's going on there. So just like I said, this will say check out a branch that will track this max branch on my server. Let's see what happens. Cool. So it says here branch max branch setup da 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 da. That's fairly self-explanatory, and we've switched this branch. So let's I don't know. Oh, he added a lot of stuff. Okay, so he changed some stuff here. Every time. Okay, so he added a PDF. Git can't diff PDFs because they're binary and they suck. Whatever. But anyway, so now we can switch back to master, do whatever we want. We'll notice that all Max's random crap is gone. And now if we want to go back to Max's branch, it's just git checkout max branch. Just like that. And we can make changes here, since I don't know. Make some change there. And we'll push up to now Max's branch. Now if we go back to GitHub, we'll see that GitHub has just been sitting here this whole time. We have Max branch, and we have all these changes from everyone. You can look at your commits, We can even see exactly what change in each commit. So GitHub is a really nice way to visualize all your changes. You can see it. Well, this projector is terrible, but if it weren't terrible, you could see that it highlights this line in green because I added it. Man, that's really kind of depressing. So that's these are the key commands for working with branches that other people have contributed to your repo. Yay? Nay?
People ask if you should merge the other branches in the master branch.
Maxing? Okay. So let's say that, let's say we've decided Max's branch is good. Actually, okay, so I'm on Max's branch now. Who wants to tell me what I have to do to merge this branch back into master? I know you guys know this. I know someone here knows this. Okay. Right. How do I go back to master first? Yes. Actually, you do it by being able to type. And then now that I'm on master, what do I do next? Does this help professors feel? It's terrible. I feel so bad for every time I didn't answer a question in class.
Git merge max branch.
Yeah, to get yeah. So that'll merge max branch into master. And actually, we'll just look. So before, we don't have any of Max's stuff in here. Now, man, it's done a ton of stuff in that merge. I'm really curious as to what server.js does. We'll find out later, I'm sure. And now we have all his commits here. And to go ahead and share this, this master with everyone, we can see this branch master is ahead of the origin. So we have more commits here than are on the server. So let's go ahead and we can share those with everyone. There we go. And now, git status, we're on master, nothing exciting is happening. So that's working with other people's branches. Fun fact that is not really important. If you don't understand this, it's not important. But git pull is the same as git fetch. So fetch all your changes from the remote, and then merge changes from the origin into your current working branch. This line is almost not a lie, but it's really, really close to the truth. If you're really interested, you can read that man page. But if you don't understand, that's fine, but it's sort of a fun note about git pull. So that's working with Git, basically. I haven't done anything that's GitHub specific yet. That will all work even if I just have a shared Git repo on a server somewhere that Max and I can both SSH into. None of that was GitHub specific. What is GitHub specific is the sort of process that they've put together for contributing to an open source project that someone else has published. Now the way that they've gone about doing this, since it's not feasible for if I want to contribute to the Linux kernel, I'm not going to email them and say, hey, can I get SSH access to the server to commit to the Git repo? It's not happening. So the way that they do is you can go to GitHub and click a button that says fork, and that will create basically a copy of that repository, but that you own. You can work in there, you can create branches, make your own commits, all that sort of stuff. And it's all sort of your own copy of the repository, so you're not breaking anyone else's stuff. Once you've added the feature that you want to add in a branch in your copy of the repository, you go back to GitHub and you create what's called a pull request, which basically says, hey, I made these changes, I added this feature. I think you should pull it and merge it into your repo because it's really cool. And I fixed this bug or did something. So I thought that the best way to explain this is probably to demonstrate it. So I think Max is doing something, but what I was going to do is one of the guys at work has this runs a site called istextmate2outyet.com, which those of you who are Mac people will get this joke. The rest just don't worry about it. But the point is, there's so on one of these branches, there's a file that needs to be updated, and so we're gonna update it and then request that he accept our update. What we're gonna do, this link here needs to be changed to something new. So The first step in contributing to this open source project, which is one HTML file, but we'll click fork, and we'll fork to C to Dzombak. And it's gonna take a little bit to do stuff. It should only take a few seconds. Cool. So now, if you look up here, you notice this is oh, does that not work? No, it don't. Oh yeah, it's working. Something. Oh man, zooming is really slow connected to a projector. That's really unfortunate. Anyway, you'll notice up here this says that this is my copy of this repository. I own it, which you guys in the back can read, was forked from his repo. But that means I can make changes in here all I want without breaking his stuff. But let's go ahead and copy this URL. So we're going to walk through kind of the whole process here, which is pretty simple as it turns out. Okay, how do I pull down a whole Git repo initially? Yes, I knew that. I knew someone knew that. Cool, so we'll clone it. Awesome. Cool. The file that we wanted to modify, I happen to know, is on... why did that not... is on another branch, which for some reason isn't quite here, but we'll figure it out. So, I know that there's this branch called gh-pages, which we want to modify a file in. So, in order to modify that, we'll do checkout -t origin gh-pages. All right, cool, and we're on that branch. So, let's go ahead and actually make this modification. Now, we're going to... not really. Just not opening at all, man. All right, we're going to open this the old-fashioned way. There we go, almost. This machine's really slow right now. Oh, I do know why. It's because we're recording this with QuickTime. So anyway, we're going to change that link to this, which is the TextMate open source project. So we'll go ahead and make this change. Save that file. But what did I say? I said if we're contributing to someone else's project, we probably want to commit this change on a new branch. So let's create a new branch. CDZ new link, because that's what we're doing. We're adding a new link. See what's different. Add that. Cool. And we'll go ahead and push that back up to my fork of this repository. Great. So if we go back to my fork of this repository, my recently pushed branches, I pushed a branch called cdz-new-link, which is really hard for you guys to read because this is tiny. Is that a little bit better? But we hit compare, and that's going to try to compare it to master. I'm not sure why, so ignore that. But let's hit pull request and see if we can, yeah. So we want Andrew Sardone to pull from my repository, from this branch, into that branch of his repository. And add our justification here. And you can click through, see what commits will be included if he chooses to accept this. See what files changed if he chooses to accept this. Go back here and say send. And that's it. That's the process. So now I've made that change on this project and requested that he accept it. And that's sort of the GitHub way of contributing to things. Now, Max said that he made a pull request on this repository that we were working on earlier, which has since disappeared. Got it. All right, well, the process of accepting a pull request is really simple. It'll show up in this list, and it'll show you what changed, and there's a big green button and a big red button. If you like it, you hit the big green button, and it accepts it. Otherwise, hit the big red button, and it doesn't accept it. There's also a comment area for discussing them, but that's really the gist of it. If we go back a couple clicks, yeah, this is what that looks like. Either comments, you can, oh, oops, went back. Computers. I can discuss this change with Andrew, argue about whether it should be accepted. I can close it without merging it in. He can actually say, yeah, this looks good. So that's the sort of GitHub way of contributing to projects in like 5 minutes. Hopefully that wasn't too complicated. And if you want more information on how that works, go here. They probably do a better job explaining it than I did. That's basically the tutorial that I had for you guys tonight. That's enough for you to be dangerous and enough for you to work on class projects with Git with everyone else. Here's some additional reading that you should check out if you're more interesting, and you should be more interested. More interested, English. If you're interested. These are both just useful resources. The Git parable kind of explains more about the core concepts behind Git, how it was developed, and it'll really give you a good feeling for how the system works and how to use it effectively. Note about Git commit message is just some guy complaining about how people don't write good commit messages, but it tells you how to write good commit messages. So that might be worth reading. Here are some more links that you can refer to for help. They're good resources. Additionally, if you have a question like a specific error message, or you're wondering like, how do I change a commit message after I've already written it and committed? Just Google like git change commit message. I absolutely promise you that the first result will be a Stack Overflow link that answers your exact question. Same with like git error messages. You'll probably find something really, really useful. Here's some other tools that might be worth checking out. In particular, that TIG tool that I mentioned is cool. It's just a nice, it's a nice tool for browsing through the history of a repo visually. Any questions? Yeah.
Does Git pull do a diff patch or does it replace the files?
It will do the git pull. It'll do merge just as if you type git merge. So for things that for errors that were changed in both branches, they were changed like on the server and locally that don't conflict at all. Two people change totally different parts of the code. It'll just take both the differences and combine them. It's in a situation like this where where someone else Max changed a line of code on the server. And I change the same line of code. When I do git pull, it will ask me to resolve that conflict the same way.
It's kind of a really complicated question. Git saves full files, not diffs, but it does diffs on them. And the reason it does that is so it doesn't three-way diffs, so it isn't really stupid. And if like two of you added two things that are close to each other, unlike SVN, it can actually know that those are two different things and just put them in automatically.
Yeah, that's true. And yeah, as I mentioned, because that Git is it's really pretty smart about merging stuff. Honestly, 80% of the merge conflicts that I ever deal with are because I'm working on our iOS app and Xcode's project files are horrible and ugly and have to be in Git. But yeah.
So I know like when you're setting up GitHub, I guess on your computer, you go in and put in the key, put in your SSH key, things like that.
Mm-hmm.
So is there any way to, let's say I was at a library computer or a Kane computer, to push something to GitHub?
So from a Kane computer, for example, if you're logged into, at least if you're logged into the Linux environment, your SSH key that's in your home directory will be the same across the whole Kane environment.
Oh, so I can set that into my account.
Right, and if you're on, say a Windows machine, even that, do the Kane Windows machines even have Git installed? I don't know offhand.
No, download Git, Tortoise Git, or whatever it's called.
Yeah.
Yeah, it works pretty well.
And you could just add, with a SSH key that you have in your Windows Kane account to GitHub too. But those are all synced with Kane's Windows profile syncing, and if it's in your shared Linux home directory, then you're good to go.
Thank you.
Yes, Max.
What does server.js do?
I don't know. I'm gonna find out as soon as I finish up. This is my contact information: email, Twitter, GitHub, because we just gave a talk about GitHub. If you have any questions about Git or stuff in general, or interested in Nutshell, you should ask me more, because I'm happy to answer questions. That said, I will turn it over to John and Gaurav and Max.
Can I make a quick note? Last semester, the education sign-up process was